All right, Dr. Lane, this is Stephen Walker. This is my reassessment on rotational dynamics. I did the assessment that we did in class because I thought I understood it, but clearly I did not, hence the King of the Ones jazz I got going on here. And so in the equation, it gives me the radius of the fan blades, and it also gives me the angular velocity, which I put in radians per second, and it gives me the angular acceleration, which is in rads. So I went ahead and put the angular velocity, which was just in revolutions, and I multiplied it by 2 pi to put it in radians, and that gives me 3 pi. So everything now is in radians. And then it says before the fan shut off, it was doing 1.5 revolutions for 10 seconds. And so that's just 15 revolutions, saving that for later. Then I use this kinematic equation right here, but I've replaced everything in forms of angular velocity and angular acceleration. And where this here is the change in x, still moving, but just in a circle. So that's radians, or it could be revolutions, but since everything right here is in radians anyway, or is about to be, I went ahead and said, that's my radian jazz right here. And acceleration equals the change in velocity over the change in time, or alpha, which is angular velocity, equals the change, or acceleration is the change in angular velocity over the change in time, or change in omega over change in time. Well, I rewrote that so I could find time since I have these two given. And so that's what it looks like, and that's going to be 3 pi over 2.2 radians, and that gives me my time. So I plug all my givens, my time and everything, into this equation, and that gives me 60.49 radians per second. However, it asks for revolutions, and so in order to convert this back to revolutions, I just divide it by 2 pi. That gives me 9.64 revolutions. And so I add the 15 from before it started shutting off and slowing down, plus this, and it gives me 24.64. Now, I didn't get whenever I obviously took the stupid test, you just wrote angular velocity, and I didn't really comprehend what you were getting at. But I made the correlation between the velocity and acceleration, but just angular, and then being able to convert it in these kinematic equations, one of the 5 that you could use. And yeah, it's really not that hard. But that's it. All right. Thank you, Dr. Lane. Bye.